Hello everyone, let's code again and solve a new problem. This time we will solve problem number 17, letter combinations of a phone number. It's of medium level. So we are given digits in a string could be from 2 to 9. Yeah. Could be, for example, could be 2 3, could be 2 2, could be 2 5, could be 8 9, could be 4 5 6, could be anything, and it requires from us to retain all possible combinations of these digits. For example, here we have 2 and we have 3. We know here from this we have 2, it could be A, B or C, and 3 could be D or E or F. So we need to return all the combination. Here we have only 2 digits. So in this example, each digits have 3 combinations. So 3 by 3, it will be 9 possible combinations. But sometimes, for example, with 9 we have 4 characters, and with 7 we have 4 characters. So it's how many characters in this digits multiply how many characters in this digits, we will get the all possible combinations. So let's try to solve it logically by writing it. So we will start with digit 2, and 2 could be 3 possibilities. Could be A and B and C. And with each character we have new digit, it's 3. So and 3 also have 3 possibilities. So with each character we have a new 3 possibilities like this. Okay. And here we have D, E, F, again D, E, sorry, not here, here E, and here F, and D, E, F. So at the end it will be either AD like here, or AE like here, or AF like here, and so on. These are possibilities. This is if you have 2 digits. If you have another digit like 5, for each combination we have 3 other possibilities, and as you see the tree grow bigger and bigger. I think down below it mentioned the maximum number of digits is 4, but doesn't matter. We will write a code that will accept as many number as possible. Only the hardware capability or software capability, it will be our bottleneck here to solve it. But here it's limited to 4 digits. Anyway, so how we will solve it? We will solve it by using backtracking or recursion. We will define a backtracking function, and we will use an index. We have digit like 2 and 3. We will use index I to know are we here or here. And I will use a dictionary to define like 2 it's A, B, C, and 3 is like D, E, F, and 4 is like something else, and so on. So we will take, for example, 2, and we will call a backtrack function, a function that will accept the index I and start with character empty, and first index I, it will be index 0, so it will refer to 2, and then it will have iteration through every character in 2, which is A, B, C, and store it in this variable here. And when we call it again here, B, backtrack function for I plus 1, because it's a new index here, the character here could be contain A, or could be contain B, or it could contain C. So when it come here, it's already have A in it, like here already have A in it, and here we'll have B in it, and we will add this new character to the existing character. And when we reach here, AB is of length AD, or AD is of length 2. When we reach the length of this generated possibility is equal to the length of digits, that means we computed this possibility, this path is completed. Let me change the color. That means this path is completed because we reached to length is, in this example, is 2, which is equal to the length of number of digits. And then when we come here, and also here will be AE, which is also of length 2. So when we complete each possibility, as start we have an empty array. We will push this result to the empty array. We append it, and we append all the results to the empty array, and we will exit, and then we will return the array. Okay, let me show you in the Jupyter Lab, and I will explain the code more there. So first, I already created a dictionary that maps each digit to its characters. Like 2, it maps to ABC, 9 is mapped to WXYZ, and so on. So first we will start with the empty array that we will store our results in it. So this is empty array, and we define our backtracking function. It will accept I and characters. Let me correct the name. Okay. And first, if length of characters, okay, equal the length of digits, that means we are done with this possibility. Characters, it will start. Let me show you how it starts, and I will show you why I put here if backtrack 0 like this, and here at the end will be a return result. Okay, so it will start first. When we call this function, we will call it with empty possibilities. We did not pick A or AD or anything at the index 0, because we will take the first digit from the digits at index 0 and do our possibilities here. But while the code is working and working and working, this will get bigger and bigger till it holds, let's say, AD. And if the input here is 2, 3, that means 2 is A from 2 and D is from 3. This is one possibility. So when we call it like this, so the cars will be of length 2 and digit is 2, 3, it will be also of length 2. So that means this possibility has been solved. One possibility has been solved, and we are ready to append it to the result. So we just do append, and let's say cars. It's a characters, like here is 8. So let me delete this. So this will happen when we find one possibility. So this the back function, and we can return here, do return, so no need to continue the code. But what if we are starting now or in the middle of operation? So this, if the operation is done, the function will return. But if we middle of the operation, we do recursive. We do for character in digits to car. So we need, for example, if it's 2, we need to iterate through A, B, C. But how we find it's 2 or what? We have this dictionary name, but dictionary name for which index? Is it for 2 or 3 or 4? We have I here. I could be 0 or 1 or something. So we transfer digits for index I, and like this. So for example, if I 0, so we take digits for 0, which will be, could be, if our digits is 2 and 3, so digit of 0, it will be 2, and digits character of 2 will be ABC. So we will iterate through A and B and C. And what will we do when we iterate through A, B, and C? We will call the function again, but updating the I to a next index, and we put A or B or C in the character, and we call the function again. So we will do backtrack I plus 1 cars plus ch, and that's it. This is the code. Let me test it. There's error, digits car, it's digit, not digits. Let me correct it here. I think digits better. Yeah. So let me take this code and go to the Leetcode and test it there. So I paste the code here. Let me submit and see if it's work well or not. Yeah, 100% time complexity, and space complexity is 23. It's good also, not bad. Now it's 92. It's different from for each test. So I think we did well here. Thank you very much for watching, and I'll see you in the next code. Goodbye.